Okay, thanks everybody, and welcome to this public forum for SZ4D's plans for infrastructure, is what all of that NSF MSRI-2 really means. I'm here with Diana Roman, who's the SZ4D co-chair and also will be the PI of our MSRI infrastructure proposal, which we think is likely to go in next year. But this depends on NSF. So I am the co-chair of the Operations Planning Committee for Infrastructure called OPCI. So that I think at least covers all the acronyms on this slide except for SZ4D, and I hope you know that one. All right, so what this is about is infrastructure for supporting the science that SZ4D wants to see accomplished. So NSF has a number of infrastructure programs, and they are designed to build infrastructure to enable research to be done. So you can think about this like building an observatory or building a telescope or something like this. And so these NSF has particular definitions of what qualifies as infrastructure and what does not. So this will be a proposal that will be related to building the instrumental infrastructure needed to do the science we want to do in Chile, Cascadia, and Alaska. And as Diana will tell you a bit more, there are, again, there are restrictions on what is infrastructure, what is not. And there are restrictions on total budget and so on. And the MSRI program would bring in a lot of money from outside NSF Geosciences to build the infrastructure, but the operations of the infrastructure come from within the NSF Geosciences budget. So when we put together some sort of a proposal here, we need to be cognizant not just of the definitions of infrastructure, the overall budget limits, but also, the operations and maintenance cost down the road. So with that, I'll turn this over to Diana. And if you're joining late, again, Diana is from Carnegie Institution. She is the vice chair of SZ4D, and she is the project PI for this infrastructure proposal. She's the one who is leading the charge to make this happen. So what Diana will talk to you about today is a summary of the current status, a summary of what we expect to be doing over the next several months to a year. And then also, how you can stay involved in that process. So I'll turn it over to Diana, and just remind you, if you do have questions, we have a Q&A box. So please put your questions in the Q&A box. I'll be moderating questions. We'll hold them till the end, but I'll go ahead and go through the questions at the end. And with that, I'll turn it over to Diana.
Okay, thanks, Jeff. And good morning, everybody. Thanks for joining us. So I'm going to aim to give you a fairly high-level overview of the MSRI program, our current understanding of it, what SZ4D is planning to propose, and basically a status update on that process and our plans moving forward. I'll try to keep my comments brief so that there's plenty of time for questions at the end. So if you have a question at any point, just pop it in the chat, and we'll try to address all of your questions today. Okay, so let me just start with an overview of SZ4D. SZ4D has been very, very busy, as you all know, for almost a decade now, but especially in the past few years. We have had several proposals funded that have supported our planning efforts. Our current one is what we refer to as the Catalyst. That's actually almost completed at this point. We have an ExcelNet grant funded that's just started. This is SCNet, which is our international collaboration arm. There's a lot of really great activities going on in that proposal. We recently submitted a large proposal to the NSF Geohazards Center solicitation. And we have numerous smaller proposals that are going in all the time to fund more targeted efforts. So this town hall is entirely about our instrumental or infrastructure proposal that is upcoming, but I want to note that we will have a similar town hall focused on these other elements that is scheduled on November 18th at 10 a.m. Pacific. And the registration link for that will be coming soon. If you've registered for this town hall, you should be receiving an email fairly soon with the information on how to register for that one, and to come and hear about the other efforts and ask your questions there. All right, so let me start with a little bit of an overview of NSF's mid-scale research infrastructure program. It has basically two levels, MSRI-1 and MSRI-2. They're basically defined by their funding increments. So MSRI-1 supports design, proposals, and construction up to 20 million. MSRI-2, which is what we are currently working towards, is an implementation or a construction of research infrastructure, including the equipment, the cyber infrastructure, personnel, with a total project cost between 20 and 100 million. So we're capped at 100 million in this. As Jeff noted at the beginning, this is for construction only. So in the case of SZ4D, these would be things like procurement and fabrication of the instrumentation systems, the commissioning of those systems, testing and integration, and the installation of those. So we are aiming to build a network. I'll show you the details later on in the talk. That will run for a substantial amount of time, and that operating cost is a separate amount from this MSRI-2 $100 million cap. That, as Jeff noted, comes from the directorate or division levels. So that is another sort of constraint, that the corresponding O&M has to be something that is possible within the science directorates. And I'll also note that the construction phase is a 5-year phase. So this is only for building things, not for doing research or collecting data. The total funds in the past for MSRI-2 have been approximately 150 to 200 million over 5 years. And the duration, as I noted, can be up to 5 years. But of course, the estimated total program budget, number of awards, award size, and duration are all subject to the availability of funds and to what NSF is able to offer. So that brings me to the timing of the MSRI-2. The current solicitation, the solicitation for the next opportunity to submit MSRI-2s has not been released. So we are kind of working in the blind, but because this is such a large and complex proposal, we are starting to go ahead with developing it. If we go on the dates of the last MSRI-2 cycle in 2023, that solicitation was posted in March of 2023. Pre-proposals were due 90 days later in June of 2023. The pre-proposal is substantial. It needs to be ideally something like 90% of full proposal. Full proposals are by invitation only. Those in the last cycle were invited in September 2023 with the full proposal due in December. And there is a substantial process following that full proposal submission, including review panels, site visits, independent cost analysis, and continued refinement in collaboration and conversation with NSF. So we do not know if this is what the dates will be like for the next cycle, but we are assuming that and working towards an MSRI-2 submission, assuming these dates plus 2 years. So basically, we are currently assuming that we would need to submit a pre-proposal in June of 2025, so a little more than 6 months from now. That all is subject to change depending on the dates of the next solicitation, the scope of the solicitation itself. So We will really have to wait and see what the opportunities are, what the dates are. But at present, the assumption within SZ4D is that we are aiming to submit an MSRI-2 in the next cycle, and we are currently working towards that because, as I said, it's a lot to do in 6 to 7 months. This is, as Jeff noted, a somewhat different type of proposal than a standard research proposal. It's much more like a facility proposal. So something like the SAGE gauge proposal or a telescope proposal or a synchrotron proposal. It has some additional elements to it. Of course, it has the project description. There needs to be a science case, and we have obviously done a lot of work in SZ4D to develop that science case. But a major piece of the MSRI-2 proposal requirement is what's known as the project execution plan. This is a very technical document that follows formal project management protocols. And it is really our current focus in SZ4D. This is a very important piece of this proposal. It is quite technical and structured to ensure that everything is planned with a realistic budget and timeline and scope and tracking process, reporting process to ensure that the project construction occurs as needed for the scope within schedule and budget. So a lot of these elements are not really elements that are easy for community contribution because of the way that they are designed. And I will note that one thing that has begun recently is SZ4D is now working with a firm called -360 that specializes in large scientific or research infrastructure projects as our professional project management consultants. Their efforts are funded by Carnegie for now to ensure that we are actually developing an appropriate execution plan and setting up the related project management, tracking, and reporting systems so that we are doing this at a level that is both meets the expectations from NSF, but also ensures the success of a project at this scale and complexity. All right, so let me get into what we are actually proposing or planning to propose, which is the SZ4D multi-hazard array. You may have heard it referred to as multi-array in the past, but it's really an array of instruments that is aimed at studying multi-hazards in subduction zones as an interconnected system and understanding the physics of those hazards and also their predictability. This started, the array started with our working groups. We have a MDE, our Magmatic Drivers of Eruption working group, FEC, our Faulting and Earthquake Cycles working group, and LNS, our Landscapes and Seascapes groups. That developed the science objectives, the science plan, the questions that needed to be answered, and the experiments which led to nominal instrument array configurations that would be necessary to collect the data required to address these large-scale scientific questions. And all of that is encapsulated in our implementation plan that came out a few years ago. Following that, SZ4D did a global survey of subduction zones and came to the recommendation that the subduction zones in Chile, Alaska, Aleutians, and Cascadia should be the focus sites or nodes for our infrastructure efforts, with the majority of that infrastructure going to Chile and some also going to Alaska and Cascadia. And I'll show you some of the geographic specificity in a few slides. We have also, through our Catalyst grant, funded an effort by EarthScope to translate these sort of notional experiments, the nominal arrays that were developed by the working groups, into what we refer to as our budget model. So basically starting to understand the cost of the kind of optimal infrastructure plan. This is an ongoing process. It's been iterative between EarthScope, the OPCI, and our working groups. to continue to refine the instrumental plan, the locations, the types of instruments, their density, and so on. So that is an ongoing conversation as we moved into more formal planning. To show you a little bit about where specifically we plan to go in Chile, our main target region in Chile is between 28 and 43 degrees south. So this large black box here, this specific sector of Chile, the Chilean subduction zone, was identified based on input from AndesNet, which is our Chilean partner consortium. This was their strong recommendation, as well as some additional siting to the north and south for the volcanic targets. And so within this inset figure to the right, you can see the nested set of instrumental arrays and their current footprints. So surface array is shown with this green box here. Earthquake array, or formerly known as mega array, is in the blue box here, and then bulk array, the majority, is here in the red box with, as recommended by AndesNet, some additional potential targets in northern and southern Chile. What are surface array, earthquake array, and bulk array currently? So this is, again, translating our notional experiments into a budget model. So the cartoons that I'm showing you, which have evolved since you've seen them last, actually have the specific number of instruments and types of instruments and numbers of those instruments that are currently in our budget model. I'm not going to go through every dot on the map, but just give you an overview of what's currently in surface array. And this is specific to Chile. I'll talk about the domestic nodes in a few slides. Surface array currently has a plan for a backbone array over about an 850 by 300 kilometer region. That's a more sparse network of meteorological stations, seismometers, and GNSS. And then within that backbone array, there are 4 watershed scale arrays, which consist of hill slope arrays of varying complexity to measure things like precipitation, stream discharge, suspended sediment, soil conditions, turbidity, and as well as stream gauge arrays on the streams in the watershed. Earthquake array currently consists of an onshore-offshore component in 2 phases. Phase 1 has a footprint similar of about 850 by 400 kilometers, with about half of that being offshore and half being onshore. The offshore phase 1 array consists of about 70 ocean bottom seismometers and absolute pressure gauges with higher density seaward, landward of the trench. Additionally, GNSS-A, again, spread over the megathrust zone, as well as a plan for offshore magnetotelluric surveys. And this is complemented by an onshore array of seismometers, GNSS, and microseismicity arrays to provide additional constraints on offshore seismicity. And many of these seismometers and GNSS, because of their location onshore near watersheds and volcanoes, may also form backbones for the other 2 arrays. The phase 2 of earthquake array is going to be a targeted densification, both onshore and offshore, based on the results from phase 1, consisting of additional OBS, GNSS, and seismometers and onshore GNSS. The current plan for bulk array in Chile is a large set of target volcanoes, with the majority of those volcanoes being in about a 1,200 kilometer strike, with some additional targets, as I noted, in northern southern Chile. We do have a preliminary list of those volcano targets. We are still vetting it internally and with our observatory partners, but we are hoping to release that list for public comment fairly soon, so stay tuned. But in Chile, we anticipate about 22 volcano sensor arrays. These are fairly sparse, multi-sensor arrays with instruments, geophysical instruments, gas instruments, thermal instruments, visible instruments, and ash collection systems that will run for at least 10 plus years to study full volcanic cycles. In Chile, we have planned to choose 4 targets within those 22 for additional dense imaging work using seismics, magnetotellurics, gravity, and also CO2 surveys. So these will be on top of these longer term sensor arrays. And again, the targets for these, we hope to make available to the community soon for comment. I do not have slides we're still working on geographic specificity in Cascadia and Alaska. We'll try to get that information out fairly soon. But I wanted to note what the current budget model contains for the domestic nodes. For surface array, there will be instruments possibly from existing facilities that will allow opportunistic studies and event response to mass movement in both Alaska and Cascadia. In earthquake array, the current budget model includes OBS and GNSS-A offshore in Alaska, as well as onshore seismic and GNSS in Alaska, and offshore GNSS in Cascadia. Bulk array also plans to have additional volcano sensor arrays in both Cascadia and Alaska, and a few densified volcano imaging targets as well in Cascadia. And again, those targets are still being discussed internally and should be available for comment in the coming months. All right. So where do we go from here? This is our budget. So based on everything in those cartoons, as well as additional components for cyber infrastructure and overall project management and other elements, we now have what we believe to be a complete initial budget model. This is based on this sort of wish list. And I will tell you that it is very likely that the budget for this current configuration will be too big to fit within the MSRI-2 budget cap. I will say that there are lots of uncertainties currently in our budget model that we are working to refine and understand, but the message that I will convey here is that SZ4D and the community behind SZ4DU will need to start planning for budget and scope reduction. I'm not going to give a specific number today. I will tell you that it's not 5% reduction. It's not 55% reduction, hopefully, but it is something that we do need to consider carefully, and we'll need to make decisions over in the coming months. And I will talk about in the rest of the presentation the plan that we have for doing that, and how you can stay engaged and provide comment and ask questions. I will, however, also note that even if our sort of envisioned instrumental plans did in fact fit within the MSRI-2 cap comfortably, a major part of our project execution plan it would still be plans for budget and scope reduction. And just at the bottom here, I've excerpted a table from the NSF guidance, which indicates that budget contingency is not required for the MSRI, but as it is for the major facilities, but it is actually highly recommended that we have a budget contingency and also that we have a scope contingency. So even if everything were to fit in the proposal and were funded, we would want to have a plan that anticipates things like changes in fuel costs or instrument costs or personnel costs, such that in the course of the project construction that we would have a plan for reducing. So this is a normal part of project planning at this scale regardless, but we do need to think about what is in our current budget and scope reduction and ensure that it meets that $100 million cap in the coming months. So moving on to our action plan for that, for the budget. I will be working with the OPCI as well as the working groups to continue to refine the budget uncertainties, to develop a schedule for construction that will help us also refine our costs, and we will continue to look at our scope. This will be done heavily with input from our working groups, with the goal of turning this budget model into a proposal for the MSRI-2 that complies with the solicitation and the budget cap, and that focuses on the highest priority science elements, the highest priority infrastructure. Our working groups will be providing significant guidance on the prioritization and any reductions that need to be made, a reduction plan. And we are committed to making this a very transparent process for both our internal SC4D committees, but also for the community. To that note, we are now following a process within SC4D of formal change control, so that every major change to our budget, our schedule, our scope will be vetted by an appropriate committee or individuals, will be logged, and so there will be clarity on what discussion on proposed changes and clarity on decisions made about those changes and documentation. So this is not going to be Diana and Jeff in a smoky room in DC canceling watersheds on their own. This will be a process that will be very formal and documented and transparent. The working groups will also continue to refine their experiment plans, to refine the footprints domestically and in Chile. So working on the prioritization of target volcanoes, watersheds, and fault segments. A key element of this is a proposal that we submitted in May that is still currently in review, that has proposed work to basically use data and modeling to assess the critical instrument topologies and densities that will be needed to basically meet the science targets, to see how few instruments we can get away with and still meet our science goals. And so if funded, the work done through this proposal would be a major basis for the prioritization by our working groups and any decisions about budget or scope reduction. Just briefly to show you a little bit about what's in that proposal, I think some of the PIs are actually in the town hall with us. We have numerous work packages that are aimed at assessing existing data sets to understand capabilities for recording certain magnitudes of earthquakes, certain scales of deformation onshore and offshore, looking at basically how we can best reduce noise in instrumentation through various configurations, how we can optimize distribution of instruments to use the smallest number of instruments to still get the most observations and signal, to look at things like how oceanographic and bathymetric conditions will affect the instruments, and how, again, we can optimize our deployments, looking at basically how we can distribute instruments through watersheds to capture the key processes on various nested scales, how we can best optimize our imaging on volcanoes, and then how we can combine all of these subnetworks into the multi-hazard network to make sure that we reduce the redundancies. Every instrument is doing duty to multiple science objectives to the extent possible, so that we have a non-redundant and fully integrated multi-hazard array that is the most efficient combined array that allows all of these various science goals to be achieved. And then finally, I want to comment on our scope refinement plan, which is, again, very similar to our budget refinement plan. Again, this is heavily done with input from our working groups, the goal of which is to optimize our scope plans based on our analysis of current capabilities and the work through the design proposal if it's funded, to look at what instrumentation already exists that we might take advantage of, so permanent instrumentation that we might not need to redeploy, whether that's a possibility. Again, making sure that some instruments, if possible, are contributing to multiple subarrays, We will be assessing trade-offs between spatial coverage and density to decide whether, if we need to reduce instruments, is it better to reduce density or to reduce the footprints. Again, our working groups will be the main source of guidance for these and for the priority target footprints and systems. And again, we will be following a formal change control process to ensure that our scope reduction plan and any decisions on scope reduction are vetted throughout SC4D governance, are communicated to the community, and are documented and transparent. Okay, so that is what I have to present. I wanted to just end with a few notes for you on how to stay informed and engaged on this process. We will be having numerous events at the upcoming AGU in Washington, D.C., including a town hall on Wednesday evening, December 11th from 6 to 7 p.m. I will provide another set of updates on our MSRI plan, our current budget, our scope, and where we're at. And we will also have a breakout discussion where you can come and provide input directly to me and other members of OPCI on your thoughts on the prioritization, on any questions you might have or concerns you might have. But in the interim, we want to, again, make sure that everything is transparent and available to you. We are currently planning to add an infrastructure planning webpage to the SC4D website that should have information like the cartoons of the various arrays, the footprints, this presentation, other information such as volcano target lists as it becomes available, so that you can come and actually find that information, and we will keep it updated as we begin to develop those pieces, and you can see the latest on the plan there and submit feedback through our website. You can, as always, email us. You can email me or Jeff directly, or Doug Weens, who is the other OpenCI co-chair. We are happy to hear from you at any time. You can email our working groups. The simplest way to do this is to send a general email to our general email address, contact@SC4D, and it will get routed to us. But again, we welcome you to reach out personally to any of us at all time with questions or concerns or comments. And then finally, again, we have our working groups, we have our various committees, they represent the community. It is a really important job, and I want to acknowledge the hard work of all of our committees and of AndesNet, our Chilean Partner Consortium. This has really been an effort of many, many people, and I invite you to continue to look out for opportunities to join SC4D governance. You can find a rolling self-nomination form on our website, and we announce opportunities regularly once a year to join our governance. So please also consider coming and helping out in developing this important piece of SC4D and in contributing to ensuring that all of the elements of SC4D are running and are the best science effort that we as a community can make. So I'll end there and turn it back over to Jeff, and we are happy to address any questions or provide what additional information that we can for you. Thank you.
All right, thanks. So there are already a number of questions in the Q&A box. If you have a question, please enter it in the Q&A box. I'll be going through those and asking them, reading them out loud. So yeah, as a few of them actually have some things in common. I'll get to that when we get to that. But please put your questions in the Q&A box. Okay, so the first question that came in was from Noel Jackson. What relationship is there, if any, between proposed GNSSA sites in Alaska and Cascadia as part of SC4D and the current community experiment sites in those same subduction zones? And I think I can answer that one, actually. The plan is that these will be complementary to the current, as I understand it, to the current community experiment site. So this would be representing mostly new sites. I think if we have input from the working groups that, for example, if some of those existing sites need to have continued operations, then that might reduce the number of new sites that we could put in. So there would be some trade-offs there. But that's my understanding, is that these will be new sites is the plan. There's a second question, which comes from Eric Fredrickson, also about GNSSA sites, and asks, will the GNSSA sites be the current standard model of 3 seafloor transponders per site, one with an APG, or is this to be determined? And Noel added, also, if there's an APG, can it be an A0A APG, so an auto calibrating essentially?
Yeah, so the current budget has A0A. I believe the current budget model, and I should say the budget model is based on sort of a nominal instrument. We have not made decisions yet about specific instruments. We're simply using a nominal instrument cost for budgeting, but we are going with a traditional configuration as I understand it, but they are A0A. But this is another stage that we will need to firm up in terms of what specific requirements for each instrument, rather than sort of a nominal kind of representative instrument in the budget.
All right, thanks. Okay, so there's a bunch of questions about operations and maintenance. I'm going to get back to those in a minute, but I'll skip to one that comes from Carlos Becerril. Are there any plans to deploy distributed sensing / fiber optic cable, i.e. DAS? And
so we have had conversations about DAS within SC4D, and we actually had a workshop on DAS. You can find that the workshop report on our website. The current budget does not include DAS, but it is obviously something that is of substantial interest to SC4D and obviously to for long-term efforts towards earthquake early warning. So there are various conversations going on about possible avenues for DAS, but not necessarily within the MSRI-2 budget.
Okay, and we keep getting O&M questions. I'm going to come back to those, so don't just wait, please. Okay, next question from Einat Lev. What is the data services / cyber infrastructure plan, and is there a budget for it? Yes,
there is a budget. We also have, in our center proposal that's currently in review, we have substantial data management efforts and data curation and serving efforts planning. So obviously this would be, the key point of the cyber infrastructure budget of the MSRI-2 would be to ensure that the data comes out to the community in high quality, consistent, well-documented metadata. We are currently having conversations within SC4D about to what extent we would also provide derived data products. I think, there is interest in additionally serving not just the raw data to the community, but also to some degree derived data products such as simple event catalogs and so on. I don't think we would be going beyond, say, a level 1 derived data product, but the main point there is to ensure that we are building an infrastructure that can house the data securely, that can ensure it's quality controlled, that it's available through standard formats, that it can be integrated into existing systems. So kind of technical data management and ensuring the data availability to the community.
Yeah, and so I would just add that there's a very, very large spreadsheet that has been put together by, actually mostly by the Operations Planning Committee A activities. So some of the data, for example, the seismic and geodetic data, we have an existing facility that deals with those kinds of data. So they're very familiar and it's very straightforward to see how those would be handled. But there's a wide variety of other kinds of data that are being envisioned as part of SC4D. So we now have assessments of, what kind of data are these going to generate, or will these instruments generate? What volume? Is there a standard repository? Is there a standard format? And so on. So there's still work to be done for sure on that, but that is ongoing. I think another element that is also ongoing is that there are elements of SC4D that are not necessarily by themselves infrastructure. For example, people collecting data of various types. And there needs to be a system for this data to be systematically stored and served up and accessed. So that is another thing that is being worked on in terms of putting that into the plan. So for example, we can't, as part of infrastructure, have a bunch of geologists go out and make measurements of something. But we can provide a data system that when those measurements are made, those data actually go into the data system and are available broadly.
Right, and we're also thinking about things like physical samples and so on. And we have some upcoming workshops on legacy data that we're trying to assess. Again, how do we integrate with existing data sets that might be of interest? As Jeff noted, a lot of this planning has largely been within OPCA, so I think this is a good topic to learn about through our upcoming activities webinar, simply because a lot of the planning to date has been in OPCA. But in short, we are beginning to develop a data management plan, and we do have a substantial part of our budget. I didn't go into the details on it. For cyber infrastructure data management for the new infrastructure that we're proposing.
Okay, I'm going to give one more non-O&M question, and then I'm going to get to the O&M questions. From Eric Fredrickson, is there a plan for or discussions around the sunsetting of all this infrastructure, contributing to existing pools and facilities, or et cetera, or what? What's sort of the sunsetting plan for all this infrastructure?
Yes, very good question. And NSF does require us to have a plan for decommissioning. This is not a permanent network. There are a number of possibilities. We have started conversations with monitoring groups on possible long-term adoption of some or all of these instruments. SC4D would love to see these remain as permanent infrastructure, but of course that is not something that NSF will fund. And so there are discussions with various agencies about adoption. Of course, another possibility is them going into an existing or new pool for use beyond SC4D. So we are having those discussions and looking at opportunities. Again, our preference would be to have it stay and continue to collect data. But that also depends on funding outside of SC4D and NSF. And we are actively working on a plan as part of the proposal on various routes that we might take with the sunsetting and decommissioning.
Okay, great. So now we have a set of questions related to operations and maintenance. I'll just maybe say a couple of things before I get into the questions. One is that NSF has given some guidance about how much ship time in particular could be available. It's a smaller amount than we want to hear. And Diana may be able to talk about if there's any sort of potential solutions to that. But also in terms of at least the familiar kinds of instruments, the ones that, for example, EarthScope Consortium has operated before, we have very solid information about what to expect in terms of operations and maintenance costs. So for the onshore arrays in particular, a lot of that, at least the seismic and geodetic, we have a pretty good idea already of what those are expected to cost. We do have to do some translation between operations in the US and operations in Chile. But nevertheless, those are numbers that are pretty solid. Okay, so we have a question about, let's see, just to put all of these together, right? So what are we planning? What can we say about the operations and maintenance planning? Is there sort of an anticipated budget? Or is this one of those things where we have discussions with NSF and they cringe or not cringe? Anyway, what are sort of the process? If you could describe a bit more about the process, Diana, in terms of planning for O&M, in terms of getting a sense of what is a realistic level of cost for O&M. And then let's do that one first. And there's a couple other points raised in the questions I'll get to after that.
Okay, sure. So again, I mainly did not focus on O&M because this is not within the MSRI-2, but all along we have, within our budget model, we have been also developing estimates of operations and maintenance, and have been making NSF aware of those. And talking about what is realistic. We also are working in parallel with refining our uncertainties regarding the infrastructure construction costs, are working to understand the uncertainties within our O&M, and NSF has specifically directed us to continue to work on our O&M estimates, and we are doing so. They have seen estimates of the O&M for the current infrastructure, and are aware of them, and have provided guidance on them. Yes, we, again, also in the design proposal, there is an effort there to also assess how to minimize O&M, or be most efficient in how to operate the instruments. So I think that's just simply a parallel process to what we're doing in terms of the construction, the actual MSRI-2 budget. I'm sorry to be vague. If there are follow-ups, I can try to get more specific.
Yeah, I'll add a little bit more. I mean, I think it's fair to say that if we put forward a plan that NSF Geosciences found to be fundamentally not affordable, that the proposal would not be funded. So there has to be, you know, we get guidance from NSF. It's imperative that we follow that guidance, really, and we have to be careful. You know, there could be some temptation. Oh, if we did this, we could cut a little bit off the MSRI project and make it fit in the fit in the budget, but then we inflate the O&M by doing so. We really can't make trade-offs like that. So yeah, I think those are kind of the main points. There's a question that came from Jim Gaerty adding to this. Could we provide a little more detail on what deployment costs are allowed within the base proposal, if any? And some of that I can address. So let's imagine that we have an imaging array that is going to be temporarily deployed on a volcano, just as an example. The purchase of that equipment, and that would be part of this proposal, but deploying it on the volcano would not be. That would be operations. But if we have a long-term instrument that's going to be out for 10 years on that same volcano or somewhere else, the installation of that in place is part of the instrument. So if we're putting instrumentation out for the long term, installation of that instrumentation is included. If we're moving it around, the moving it around part is not included. And of course, the operation, just paying for the telemetry and data handling and so on, is also part of operations. So yeah, Diana, do you want to say more about, there's also probably a question about, in particular, offshore, you know, what is a deployment cost versus a purchasing procurement cost in that context?
Right, and I guess maybe what I'll say to this, and again, not because it's such an it depends thing. What I will say to this is that this is basically an ongoing conversation with NSF to understand both what is and isn't allowable as construction or deployment, and what is truly operations and maintenance, and also what does that do to our budget and schedule. So it kind of is an it depends to some degree of whether you can justify something as deployment versus operations, but our main approach is to bring those specific questions to NSF, and to ask for guidance, and also to look at how that might impact our balance of budgeting within the MSRI and within O&M. I have a long list of a next set of questions on exactly this topic that I will be sending to NSF and looking for guidance on as we continue to refine the plan and look at individual elements and the gray line between deployment and operations.
Yeah, and then one last O&M question is William Wilcock asked about the cost. Well, again, we've sort of talked about that to the extent that we can, but also where does this come from? Which programs do these come from? That last part is largely an NSF question, not really, it's not like SC4D is going to be writing a proposal to the geophysics program to fund the operation of this. It would be much more like how NSF funds the gauge and sage facilities, presumably, or things like that. So I don't know if you want to add anything to that, Diana.
No, I think that's probably it. Whether it's kind of within NSF to decide, where and how that comes from. Obviously, we are onshore and offshore, so we have ongoing conversations with people in OCE and EAR. But within NSF, whether this comes out of existing budget or existing programs or new funding to the NSF budget, that's sort of beyond our understanding, yeah, it's not something that is really in our purview.
Yeah, okay. All right, we have a question from Yuning Fu, who says, maybe I have missed this, but what is the role of EarthScope in this proposal/project? And well, first of all, EarthScope personnel have been funded to actually help develop this budget model and so on. So that's work that's basically completed already. But obviously, seismic and geodetic data will go to whatever is the successor to the SAGE and GAGE facility. We hope that will be operated by EarthScope, at least I can say that personally anyway, but NSF has not yet decided who will be operating that facility. So, Diana, do you want to?
Yeah, I mean, no, this is just to clarify, because yeah, maybe I should state this obviously. So right now I'm the lead PI of this MSRI, but there will be subcontractors and one or more subcontractors that will be handling a lot of the actual kind of doing. I do not anticipate that Carnegie will be buying all of these things and constructing them here. We have been very closely engaged with EarthScope from really the beginning, and we are going through a conversation within SC4D about our making the formal decision on who we would see as subawardees. But the general structure currently of the proposal is that the overall the oversight office, the overall project management office, is something that I will be running here at Carnegie, but we would have one or more subawardees like EarthScope that would be doing what they know how to do best, and so that's the general model, I guess, is if that clarifies.
Yeah, okay. All right, we've got a question from an anonymous attendee. For subsurface structures that vary with time, so the 4D component, what's the depth target? Like, are we only looking at near surface, like shallow as 10 kilometers, or targeting a much deeper depth such that the whole subduction zone? So yeah, what's our...
Yeah, well, given the focus on hazard and predictability, and this goes back to early conversations at the Boise workshop, we're not looking at mantle flow or larger scaled processes, but obviously, subduction zones are a system that extends quite deep, but the decision has been made generally that the focus is on events within the crust, not necessarily just within the upper crust, but where do the most important processes occur in the context of the geohazards and potentially their predictability. So obviously the networks record what they record, and hopefully this data would be extremely valuable to questions beyond SC4D's scope. But we don't have a strict depth limit, I guess I would say. I know, just speaking as a volcanologist, that one of the aims of the Volc Array is to look into the deeper roots of the volcanic systems, both in the long term, in their how they vary through time, but also their structure. I think, obviously landscapes and seascapes is a much shallower suite of processes, but ultimately what we are doing in SZ4D is not thinking about it as so much as the individual processes, but as how they interact with each other, and really how a subduction zone system produces these events and also produces signals of these impending events. So that to some degree requires every individual process to be linked into a broader context that gets into the deeper subduction zone system. So the 5-cent answer is, it's not the transition zone, it's not the lower mantle, but it's really more a question that's answered by what depths do we need to understand the process, and also the broader process of subduction zones and events within subduction zones.
Yeah, so again, just again, another example in terms of faulting and earthquake cycles. For a megathrust earthquake cycle, you need to go down to the base of the seismogenic zone in the megathrust, and actually a little deeper, because you probably have creep events of various types that are occurring near what we would call the down dip end of the seismogenic zone. So, so it does depend, but it is, surface array is focused on surface processes. That one is focused at really the surface processes, but the other arrays really are focused on lithospheric scale, essentially, between the megathrust and the sort of crustal volcanic system. Although again, with the hazards emphasis there, a lot of that volcanic system is focused on things that erupt. And so it's going to have a bit of a weight towards things that are relatively closer to the surface in terms of the science processes that were targeted. Okay, I think it answers enough of that question. We've got one last question, which is about estimated annualized O&M costs. I think even if we could answer that, the number would be currently wrong, because we are going to have to reduce scope. But anything more you can say about that, Diana?
No, and I apologize that I'm deliberately being vague here, but it's simply because I don't think that we have enough of a handle on that number. I will simply say again that NSF is aware of those numbers and has provided feedback on the extent to which they are or are not possible. And we are continuing to work to refine them. Obviously, we would like it to be as little as possible, because we don't want to impact other programs. But this is a major effort, and the O&M is percentage-wise not inconsistent with what it takes to run infrastructure at this scale. Is maybe the best I could say.
Okay, thanks. I think we are out of time now. So thanks to all of you who attended. We still got 40 or so participants online, which is great. And the recording of this will be made available. So with that, I think we'll thank everybody, and thank you, Diana, for all of the information. And if you have further questions, maybe quickly put up that last slide again. If that's possible, just to remind you. But you can always send to contact@sz4d.org. That's you'll find that in the chat, and then messages will be relayed if as needed. But yeah, please look for further opportunities to give input. We are going to be we have working groups. Talking to your appropriate working group for whatever question or issue you have is the way to go, and volunteering if need be. But yeah, we need to get the community to help make those prioritization decisions to come up with the best overall program. All right. Well, thank you, everybody. And with that, we'll close the webinar.
Thank you, everyone.